Okay, hopefully everything is working. Oh no, I don't have the chat going. Well, I can't see what people are chatting, so that's already good. Oh, let's see. Okay, it's loading. Cool. Now I can see the chat. Awesome. All right. All right, is the stream going to work first try? Can you tell me it's working? Can you see me? Can you hear me? Seems like yes. Can you hear me? Okay, it looks like someone is going to make a Desmos notebook while I work, so that could be cool. If you're hello there, everyone. So I'm going to be making a Desmos notebook. Feel free to make yours on the side or to give me ideas. These are my 3 ideas for Desmos notebooks, just based on stuff I've been working on or interested in. I'm probably going to do the first one, and if it's going poorly, I will stop and maybe do something else. Maybe something simpler, like something from high school math or something like that. Or you can give me ideas if you have one. Oh yeah, this is not a Discord voice call. This is just a live stream. So this will show up on my YouTube channel after, so people can get ideas for what you can do with a Desmos notebook. Yeah, so welcome everyone. I'm gonna work on a Desmos notebook about metaballs using implicit, I guess they're inequalities. I'll call them relations for now. If anyone in the chat is better at math than me, you might be able to help me. I made like a little outline / rough draft earlier today. So I have an idea of what I want to do, and it seems to be pretty good. My idea is basically in Desmos Notebook, you can have 2D graphs and 3D graphs right next to each other using the same variables. So it's going to be cool to see how things show up in 3D, and hopefully that'll show what's going on in 2D as well. Okay. Oh, I thought you could do median for median you could do for animations. And I don't know exactly how to do that one, so I'm not going to do that. I'm going to rename this one to Metaballs Explainer. And then if anyone's in here who doesn't know, I am doing a Desmos Notebook challenge right now for the month of July. And if you make an awesome Desmos notebook, you could win a prize from store.desmos.com. You could win one of these prizes. They gave me 3 to give away because they really liked the idea. It's their new product, Desmos Notebook. So they were happy to kind of sponsor this one. They're not paying me to do it, but they're giving me a couple prizes to give out. Okay, so the first thing I want to do is I think there's several ways to make metaballs, and first I'll show what they are for anyone who doesn't know. I know there's a lot of people who are super advanced in Desmos and computer graphics, so you already know what that is. But let's show it for everyone watching after or anyone who doesn't know. So basically, there is a way to make balls, kind of circles come together and make blobs. I'm just going to try to do the simplest one. Okay, and then I will make it so you can drag it. And less than 0 probably. Oh, less than 1, greater than 1. I always forget if it's less than or greater than. And we're going to explore that a little bit, why it's greater than 1 here. Okay, so I have one circle, And it turns out that I can add more by just adding more of these terms here. So I'll just copy everything and I'll do x2, y2. And I will make it so you could drag it. And what happens, if I did it right, is when I come together, these kind of blend together really nicely. And I can even do a third one if I want and have them blend together. I could change the radius of the circles. If I change this to like 4, it'll be a radius of 2. And so the balls are kind of coming together. All right, let me check the chat. Okay, people are talking about using median. Okay, cool. Yeah, metaballs are awesome. I think it's like a classic computer graphics thing. This way of doing it, I'm going to explain where this equation kind of comes from. I don't know. I'm not like a full expert on this equation. It's just what I've discovered in doing that, and I've been looking into implicit relations lately. So I'm not going to fully understand this, but hopefully we can get an idea of what's going on. So what we have here is a function of x and y on this left side. And so maybe I'll write for a Desmos Notebook, I'll say, these are metaballs. And maybe I'd have an animation going or something just to kind of show that they are, maybe I could have x1 kind of going there and showing it, and maybe it'll play that. And let's see, can you drag it? Yeah, you can drag while the animation is playing. Probably don't want to drag the big one. Oh, I can grab it in the middle, but it stops. Okay, so maybe I'll just make, these are metaballs. Try moving around the little one below to see what happens. So I'll maybe just have one of the circles playing, and I'll keep that one there. So I'm going to turn off x1, y1, and maybe I'll make sure that my x doesn't go off the map like that. I'll have it go from -8 to 8 or something. Or let's go 7. 7, and then I think if I save this, I think it will just play. Let's see. Yes. Okay, so when I open it, it plays. This is already kind of cool. I guess I could do a third one if I want, but I'm just going to show, I'm going to try to be simple. And oh, the live stream is better than last month. Cool. Yeah, I'm figuring some stuff out. I listened to one of my live streams back, and I realized every time I move my mouse, it would make this loud noise. So I put it on like a notebook, so it's not as loud. Thank you. It is a nice lamp. I might have to turn it on. I was worried about the light from my window. If it gets too dark out, it's not going to work. Oh, you've been using max, min, 1, x, 0 is that for metaballs? Yeah, I think you can use max and min. It's just, this is the equation I found on Wikipedia when I searched up metaballs. There's like an actual, the example, actually, one of the example notebooks uses metaballs, and I think that's kind of how I first saw this a few months ago. But it uses stats to figure this out. So I'm kind of basing, you see they have it playing like that. I guess I can have it go in a circle. Well, I'm not going to copy what they do. But the idea is you can use statistics to figure this out. And we're going to kind of do a similar thing, but we're going to use these implicit relations. Okay, cool. So, all right, that looks good to me. I guess I'll pause that for now so that it's not bugging me. All right. Equation for these metaballs is, and then let's copy this equation. is that? Let's explore why that equation works, or how that, why, would it be why or how? Let's explore why that equation makes these interesting blobs. Okay, cool. So the idea is to do that, let's just look at the first term. And the first term is going to be that, just to simplify things. Where does this come from? Well, the equation of a circle, I guess it's the implicit equation of a circle. Maybe I could do a hyperlink to what an implicit is. Let's see. Can you do hyperlinks in here? I don't know if you can do hyperlinks. Maybe I'll just write it later. Is this stuff equals r squared? Okay, where x1 comma y1 is the center of the circle and r is the radius. Since here we'll let radius equal 2, which 2, so for now, I guess. So we have this equals 2 squared, which is 4. Okay. Now I want my circles to be shaded, my circle to be shaded in. So I'm going to use an inequality and make it, and maybe I can show a graph each time. And I haven't been looking at the chat. Maybe people are saying that. Oh, if you paste a URL in a comment, it can turn into a clickable link. Yeah. Oh, okay. Links do work. It just doesn't give it custom text. Okay. So maybe I will like do the implicit relation, Wikipedia, maybe implicit function. So I guess I'll just put that there from now, and you can see an example would be the equation of a circle here. I'll just do that. Okay. What was I doing? Maybe I'll show a graph of this graph. And I'll go like that. I don't know how many graphs I can put. I'll also make the center at 0, 0 for simplicity too. Just for now. So then we have x squared plus y squared equals 4. Okay, cool. All right, so we don't need that. Okay, so we have that equation just shown below. So I'm going to use an inequality, and then I can do another graph Could I copy this graph? Yes. And I'll do less than or equal. I wonder how many graphs you can put into a notebook. Was it only 5 or something, or am I making that up? Okay. Maybe someone knows in the chat. Does anyone know how many graphs I can put in here? I guess I'll find out. I don't know how long I can make a notebook. Oh, maybe I'm thinking 5 megabytes for the you can do infinite. Okay, it's 5 megabytes for like images or something. Is that where I'm getting 5 from? Okay, so let's divide both sides of our inequality by x squared plus y squared. And we know we're allowed to do that because if x squared plus y squared equals 0, we'd divide by 0, but that's never going to happen because our circle won't exist if x squared plus y squared equals 0. So I don't know if I have to write that. No, I'll do it. Note that we are allowed to do, I don't know if this is formal terminology. We're allowed to do this because x squared plus y squared will never be 0. Or else we wouldn't have a circle. Let's just check that. Oh, x squared plus y squared could be 0. What am I talking about? At 0, 0 it can be. I guess there's technically a little hole in there. There's going to be a tiny point that doesn't exist. There's probably a point right at the origin that doesn't exist. So I'm just not even going to put that. But there's like an invisible point right at the origin that probably isn't going to be shaded in. But that's okay. So if we divide it by x squared plus y squared, then we have 4 over so that means that 1 is less than or equal to 4 over x squared plus y squared. And putting this is equivalent to, I just like this stuff on the left side. Oops. This is equivalent to, why can I not adjust this? That's weird. Maybe it's pasting as an image or something. Who knows? So that's equivalent to greater than or equal to. That is why we have this greater than or equal to sign up here instead of a less than or equal to sign. That's where that comes from. So, okay, so then we have 1 is greater than or equal to x squared plus y squared. And I guess I could show that again, although it's going to be the same. It's going to show the same thing. Oh, what did I do wrong? What did I do wrong? Oh, I switched the sides, but I didn't. I switched the signs, but I didn't switch the sides. Well, I'm glad I checked now. There we go. Okay, cool. I'm just reading the chat. Please write the equations on the same line as the descriptions. Ooh, okay. So like that. Yeah, that does look better. Although that one, I think the colon is messing me up here, this thing. Is that what you meant? Talus of Miletus? Okay. So this is where that first term comes from. But what I want to do, I'm trying to think if I should do it now, is look at it in 3D. Let's look at it now. Maybe I'll move it though. We can think of this thing as a function, f of x comma y, where you input values of x and y, and you get a value as an output. In that case, we can graph f of x, y in 3D, where f of x, y equals z. And then I'll put like the 3D graph. Okay, so I don't know if that's the best explanation. Part of this is how do you explain math well, and how do you do it in a nice way? I guess that's really the key. Okay, so if we now graph this in 3D, we have f of x, we'll just put f of x, y equals that. So we get this like volcano thing. We get what I call the volcano function, which I just named. And if we zoom out, it goes on forever upwards. Why is it a volcano shape? Well, as x squared plus y squared gets smaller, 4 over x squared plus y squared gets larger. As you approach 0, 0, f of x, y approaches infinity. So it's going to get infinitely tall at approach. You can put the graphs next to text. Oh yeah, you can do like columns. I forgot. Thank you. Let's see. Oh, it's this thing. Thank you. Yes, I haven't made a notebook in a while, and it's kind of new. So maybe we should do that. Yeah, let's do that now. Let's go back. I don't want it over there though. Let's insert a column right, and let's put that in there. And let's do the same thing here, and let's put that in there. Kind of like it like that. Okay. I guess I don't know if I really need this one here, but that's okay. Okay. Kind of like this one below it. Might look good to the side. Let's see. Ooh, there's a motorcycle outside. All right. Let's put that in math type. Z equals f of xy makes more sense. Okay, cool. Thank you. Yeah, I'm not really a mathematician, more of a like secondary math teacher. So I might get some of this stuff a little off. Okay, that looks pretty good. So you get a volcano. Why is it a, maybe we'll put this in there then, since we have some space. Okay. And I'm going to make that in math type too. Okay, cool. All right, let's preview this. Let's take a look at, well, this is going to be playing, but you can move this around. Although, I don't know if it has to be playing. I could have a third ball there moving around, and then you can move this one. I don't know. Where does this come from? Yeah, maybe I will just move this up here. That looks much better. Yeah. Okay, cool. Let's just delete this graph. We don't really need it. Okay, this is looking pretty good so far. It's kind of what I was imagining. All right, the other thing is, so the next thing I wanted to show in this is basically, let's copy this. Let's do 2 columns again. Basically, I want to show that as this so is the same as saying as a slice, I guess it's a slice of is where z equals 1 on our volcano function. And then maybe I will let them, definitely have to change that color. So what is the best view of this? I guess that's our circle. Yeah, it looks best down here. Maybe I'll show the volcano a little bit. You can slide. Can I add a slider into here? Let's see. Okay, this is the first time I'm adding a variable into my notebook. So let's insert an expression. Or you know what? Let's name something Z1. And I kind of like clicking this to connect it to the notebook. And then I can add a slider. Let's see, can I put it in here? Yeah, I can. Okay, so now I can move it up and down and see my circle kind of grow. So I really only want them to slide from like 1.5 to 0.2. Oh, what just happened? you can slide Z1 to see how it would look. Ooh, and then maybe I'll show it in 2D. Oh, I'll show it in 2D also. Okay. Make it orange. Oh yeah, can I make it translucent? Let's see. Oh, is that better? How do I want to show this? I guess should I do any other? Oh, it looks like you can't reverse contrast. Let's see about that. Disabling lighting. No, I kind of need the lighting. Although this looks good. Kind of like showing it like there. Let's see, if I preview this, they can manipulate this, right? Yeah, okay, well, I'll just leave it like that, and they can move it around if they want. Okay, but I also want to make a new graph, and I want to use Z1, and I'm going to use Z1. So as I move Z1 now, it's going to show, oh, maybe I should make that one, this one purple to show it. Nice. Okay, well that looks really bad formatting wise. Maybe. No. Maybe we take this stuff out. I don't know how to. Oh, I'll move it above. Oh, I'll move this below. Let's do. Actually, let's keep that there. Let's put this one there. To see how it would look in 3D versus 2D, depending. How would I explain this? Let's see. Put the circle in the 3D graph. Circle in the 3D graph plus what Talus said would go. Wait, why not f of xy where it's less than z1? Yeah, I was thinking that. That's probably better. What? Or I could do a cylinder. Cylinder's kind of fun. Doesn't like really make sense for the graph, but okay, wait. Does that look good? Is that kind of what you meant, Talus? Oh, sorry, I haven't been reading the chat. Okay, hold up. Graph a curve where the plane and the volcano intersect. Right. Plot the intersection of the two surfaces. So just do that. That's not what I meant. Ugh. I can't think of the equation for the intersection. I'm blanking. Okay, add a line z equals z1. Z equals z1 equals. Can you do 3 equalities? What? Oh, the curve is at z equals z1. Use f1 curly brackets f2. Yeah, I was thinking just doing that. But it doesn't raise. Doesn't seem to like go up and down with it, and I can't think about why. So let's see in the comments. Oh, I defined x and y twice. Well, that looks good. I'll just keep it like that. Yeah. Let's just copy what you have in the chat. Well, might have to come back to this because I can't. Having a brain fart. Okay, I'll try putting in what Ramonor said. I'll try it again. Oh, that seemed to work. Oh, that did work. Now, why does that work? I guess it was kind of what I was trying to do before. Put all in one line. Do I need this purple one now? Kind of like the purple one. But maybe. You're doing one about gravity? Cool. Ron Winor just says random stuff and it works. It's true. I don't know how he knows this stuff. It's crazy. I mean, I guess you just do a ton of Desmos graphs and you start learning more and more. I think that's probably the way to do it. I'm trying to decide what looks the best. I guess I could keep that like that and make this thicker. No. I just wanted to show that it's a slice of the Z. I kind of liked how when I did Z equals Z1, it does like a slice of it. Kind of. But this is nice. Well, let's make it. This does show why it looks like that. Yeah, this does show it. Yeah, I like it. But we can make it bigger. I don't know why I was going to 1.5. Oh, 0.2. Let's go to just do it like that. Okay, that kind of shows it. I guess I could have it be an animation. Don't think I need this translucent anymore. Although it kind of looks good translucent. But maybe not. Okay, that looks cool. All right, let's pause it. All right, awesome. All right, let me check the chat again. You can make a custom color for the curve and make it slightly brighter or darker. I was thinking that. I tried that earlier. Yeah, I can make it brighter or darker. I wanted like the opacity to go down, but I couldn't change the opacity because there's not enough like options here. But I could do that. Let's see. Let's see how it looks. What is purple? I could do a HSV color picker and pick a color. I want it like purplish. Yeah, that's kind of nice. That already looks pretty good. So 275, 45, 100. 275, 45, 100. 275.45, 1. Oh, HSV. Yeah, that looks pretty good. Let's see how it looks on here. Might need to do translucent again. Looks kind of good. Yeah, that looks good for what I wanted because it kind of shows that it's a slice. I don't know what I was about to write there. Okay, cool. So that's the idea. And the next thing I wanted to do, and then maybe I'll stop because I might get stuck on the math there. The next thing I wanted to do is show how this would look in 3D. And I'm pretty sure it's going to look like a double volcano. But I actually, this is as far as I got in my like rough draft. I just had this idea. So, and I don't fully understand the math, why like adding the second term is what you would do and you add another term to get another blob. So I don't fully understand it. So I guess we will discover it together. Now let's look at adding in another term. Okay, we'll add a column. And let's copy this. Let's copy this. Let's name Z2 instead. Let's name it Z2. We'll name this Z2. Okay. And moving the center of the circles so they aren't on top of one another. So we want to see basically two. I think it's going to look like two volcanoes. We just want this. This happened to me last time. Okay, let's define, let's call it g of x. And g of x will be that. Okay, is it working? Is it back? Oh, Desmos woman ate my router. Oh, it is back. Okay. I don't know. I'm having trouble with it. All right, I'm gonna try to keep streaming. We'll see. We'll see how it goes. I don't know. I don't know what the deal is. I'll just keep trying to make this. So, what you probably missed when it was going offline is I was trying to connect this to what's over here, and I made a ton of variables, but they're not connected. They're called the same thing, but they're not connected. So I might need to define the variables before making the graph. So maybe I will delete these and redo them. Let's delete them. Let's make oh, it's kind of working. Okay, well, we'll see what happens. It's semi-working. I wonder if I could make it like a lower quality. Maybe I should do a... Let's do a speed test. Wi-Fi seems to be working. I wonder if it's YouTube. Maybe I need to restart the broadcast. Okay, I'm trying it again. I'm seeing like green in my OBS. Let's see. Hello, hello. Can you hear me and see me? Smooth video. I don't know what that means. Oh, change my settings maybe. Okay. Seems to be working. So I'm just going to keep going. Yeah, sorry about that. I don't know what's going on. I'm not a big expert in streaming. So part of this is me figuring stuff out as I go. I think it was something in OBS, which I'm streaming from. So I closed out and opened up. All right. So what I've done while it was not working is I made these notebook variables, x1, x2, y1, y2. And then I'm going to have, I guess I don't. Do I need them in here? I mean, I could just hide them, but. Okay, it looks good now. Cool. Yeah, I think it's because I figured something out. All right. Now. I also need to find Z2. Z2 equals 1. And we'll make that a slider as well. Okay, cool. So we want the slider, same deal, to go from like 2.2 to 4.5. All right. I think that's what it did. 0.2, 4.5. All right, awesome. I'm going to copy this graph. And I'm going to copy this graph. I'm going to change them to Z2, Z2, Z2. I'm going to make this Z2. And then I'm going to add in the other part of the equation, which is this part. Oh, I also need to add an x1 and y1. Let's see what happens. Let's do that first. I love how you're in the middle of something and you accidentally make like a weird hyperbolic something. Well, that's kind of cool. We have this like, is it like a conic section or something? Whoa. We've got a parabola in 2D, but then in 3D we have this cool surface. Hi, welcome back. Oh, you can't do notebooks on a phone. Nice. Hi, welcome back. I think I figured it out. I don't know. I had to restart OBS and it seems to be working now. So yeah, let me know if it stops working again. I'm just messing around now. I found this cool shape. Just messing around, but we want to square it. We'll kind of want to see what it is. What if I cube it? No. All right, I'll stop messing around. Okay, so now, and I want to be able to drag X1, Y1 around. That drags that, but then I need to also do that to move the center of the circles. No. Okay. So now as I move this around, if I move this around, this should match. That's kind of weird though, but something's off. Oh, it's like this. So it should be like, there we go. Oh, doesn't want to go below the x-axis. Yeah, I really like, I think the best thing about notebooks is putting the 2D and the 3D graphs next to each other. I think that's like the coolest part of it. Like that's honestly, yeah, you can explain stuff and do sliders, but you can kind of do that in a regular graph. What you can't do in a regular. Can you see me? I'm doing a speed test. Yeah, it's like dropping 88% of the frames. Can you hear me? It's back. Okay. Oh, yeah, it looks back. I don't know. I'm trying to do like a speed test, but it seems like my Wi-Fi is working fine. I don't know if that's a good number. I think I've been having problems with the Wi-Fi. I might have to like call the company or something. Oops. Streaming stuff. All right. We'll see how long we can be back for. Basically, welcome Seesaw. I don't know if you're here still. You did not cause this problem. It happened before. I think it's mine. But basically, I got this. Yeah, it might be an OBS problem. I've been having some problems with the Wi-Fi once in a while. I don't know. Could be OBS because it's not. I looked at my. I'm not using that much of my computing power. I'm using like 5% of the computing power. Ooh, I could plug the Ethernet in. No, I don't have the Ethernet plugged in. I would need a really long cord. But that's a good idea. I could get a really long cord. Maybe it's just having trouble connecting to the router. Good point. All right, cool. So it works now. Awesome. We'll see how long we get to stay. anyone who watches this back later is going to be very confused, but that's okay. So I've gotten this working, moving this around. So now I'm going to go and add in the second term. Okay, Ethernet cable could resolve it. Cool. Yeah, clearly I'm not like a computer expert. Okay, and then if I add in that second part to my 2D graph, and I do x2, y2, and maybe I will keep these all purple. Sure. Doesn't seem to be matching up because my radii seem to both be 1 here. What's going on? Oh, it's multiplying. Okay, it's multiplying. Forgot to add. All right. My blobs look better now. There we go. I'm wondering, is the radius of this circle 4? Might be. What math did I do wrong up here? So radius 2 made sense. Radius 2 made sense. Yeah, this is the point where I don't fully understand the math behind this full equation. So I was trying to explore it with the notebook of having stuff side by side, and to understand it better myself. It seems like when you add the term, the metaball gets bigger. Although, no, actually on the 3D one, it does look like it has a radius of 2. So maybe maybe I messed something up here. These equations look the same to me. Maybe I'll copy this one in so I can look at them side by side. Okay, it looks like we got... Oh, it's back. I think we're back. Why, as soon as I run the speed test, are we back? That's so weird. Yeah, it doesn't seem like my internet's off. It might just be the connection. Yeah, I don't know what's going on. Maybe I should Google this now. Why does my OBS drop my frames and kbps when streaming? Yeah, it seems to be working now. It's dropping. I don't want to read the AI thing, but let's see what this says. It's a network issue. Dynamic bitrate. Oh, doing the speed test might trigger something? Yeah, now it seems to be only dropping 7% of frames. Weird. Sorry, I'm looking this up now because this keeps happening. Network issue between your computer and remote stream ingest server. Such issues can be a variety of reasons. Different server. Lower the bit rate. That could help, but it seemed to be dropping the bit rate to like 0. Huh. I could try streaming. Maybe it's the connection to YouTube. Could try doing a Twitch stream. Okay. So it seems to be maybe a wired thing. So I should order a long Ethernet cable. I'm living and I'm learning. Okay, we're still going. I guess I'll keep streaming. If it drops off again, I might just stop. So I'll say bye now, just in case we drop off. This has been cool. I'm learning. I feel like I'm learning as I go. All right, welcome back. It's working for now. It might drop off in a few minutes again. I think I need an Ethernet cable. Seems to be. This is awesome Desmos activity. Meaning dropping the stream. Okay, this is no longer connected. What I don't get is why I have a notebook variable and then I have a graph variable. Like why? Because here I have a graph variable, but it does affect both. Like it's a graph 5 variable. Yeah. Something's weird. Maybe if I unlink it here. Yeah, I don't know why I can't connect these two Z's. These are connected because we have like a global variable there. Or like a global notebook variable. But Z2 is in there. But Z2 doesn't like the 3D graph. I have it defined in both. Should I just get rid of this graph and remake it? Yeah, it's defined in graph 7. But even if I... Oh, there we go. You're right. Okay, that was easier than I thought. Okay, and then what did I do wrong here? What's going on? Oh, I was just checking something there. Okay, let's see. Okay, that looks pretty good. I still need to understand, like, mathematically why we have a double volcano. I understand totally why the first volcano comes up, because we said as we approach, as these get smaller, we approach infinity. Okay, I think I get it actually. As x and y approach these centers, x1, y1, and x2, y2, as they approach those centers, that's where they approach infinity. That's where like g of xy will approach infinity. So if xy is like at I don't know, right there at like -2, comma 2, then we will have is this x1 or x2? Yeah, then we will have this being really, really small. And so 4 divided by a really, really small number is going to be a huge number, and this part won't matter much. It won't affect it too much. And then why, when I get them close to each other, do we have like a blob effect? Like, why does that come together like that? I guess it's just that the volcanoes are getting really close together, and as the volcanoes get close together, they kind of merge. It can shadow a variable from the notebook. Yeah, it seemed like a shadow. Like it was defined twice and being weird. So I did this, but I did the same thing here with graph 5. I have 2 Z1s. Oh, no, I don't. I have 1 Z1. Never mind. Never mind. That makes sense, I guess. Okay, so I guess I could explain that, why we have the blobs. Or let's try adding more blobs / volcanoes. Purple plane, half transparent. I don't think I can make the purple one half transparent because I can't change opacity. But maybe I could do this. That does look better, actually. You're right. Yeah, I think that does look good. Yeah, then you see like the whole volcanoes as you go. So in 3D, I guess these are volcano blobs. Well, you know what would be cool is to see, another thing we could do is look at the metaballs in 3D, but you would need like a 4-dimensional graph to show that. But I kind of want to, okay. Ideas for next steps. Oh. Adding more blobs and volcanoes, that would be pretty easy. Or doing 3D metaballs. I just want to try doing 3D metaballs for fun. Let's do it. Okay, let's copy the equation. Let's copy this graph. And instead, let's add a Z component. It's probably like a 4-dimensional volcano. Oops. Oh, it's not going to be Z1. I guess I'll call it Z3. That's annoying. Oh, beta 3D? Can I do beta 3D inside of the notebook? I've never really done beta 3D. I've just done that hide the box link that I think it was Lonehead Ruler made. Okay, so then I don't need the slices anymore. Oop, what did I do? I don't need that. I don't need the color. And then let's do this. Okay, so now we have 2 meta balls, and if we move, okay, that moves that around. Oh yeah, they're connected. Oh, cool. Well, this is kind of fun. So maybe I don't even need Z3 and Z4. I could just keep them on the XY plane. It looks kind of cool. Change Z1 and Z2 to threshold. Yeah, probably. I just kind of like that it's like it's literally Z equals. And so I wanted to do Z1, Z2, but it's not amazing. What I could do is actually copy this graph. Have them next to each other. Or I could make this one different. Problem is I don't really know how to explain the 3D ones. Other than, well, I guess it's the equation of a sphere instead of an equation of a circle. So it would make sense. It's just that now we have the 4th dimension. Yeah, I don't know anything about console commands. I'm not really. Have one 2D be XY, another one be XZ. Oh. Oh. Okay, hold up. Let's see if I understand what you mean. Oh, that's not what I meant. Well, well, that's kind of fun. Randomly. No, I need Z4. So your idea is to copy this graph, but instead of you said XZ. No, that doesn't make sense. Yeah. I think I understood. Yeah, you would move them around. But I need to make them a global. I feel like after an hour and a half, my brain stops working as well. Okay. So I don't want to double define them. That was the problem. C3, I need to make. Okay, cool. So now this is making it go up and down. This isn't matching though. Oh, because I made one of them. All right, cool. Interesting. All right, so I mean, I don't really, now it's just cool. I don't know if this is like getting me to explain the. Like this moves it, the XY plane. This is the XZ plane. Yeah, I should take a hydration break. I think I can do like a break. If I'm on YouTube, I think I can do like a break and it'll put an ad or something. But I don't know how to do that from OBS and it doesn't really matter. Let's see. Yeah, the 3D one is the big one. Yeah, exactly. I was thinking the exact same thing. Yes, I'm with you. This is funny. Okay. I guess I could kind of label the y-axis as Z or something if I wanted to. Like I could turn that off, but make a label. Do something like that. Of course, I want to do it in nice math type. There we go. That doesn't look better though. No. I'm all about cool, not useful. That makes sense. Yeah, I don't know if it really explains like what's going on with the metaballs. Like the point of the notebook was to kind of explain. So yeah, I feel like this is pretty good. One of the reasons I wanted to pick this one is because my I want to make my Jujutsu Kaisen animation better. And someone had the idea of using metaballs. Nope, that's the exact same graph as before. And so I made this thing a while ago, and I wanted to explain how it worked in a video maybe. And so it works using the same equation. So the purple one is using the exact same equation that we've been using this whole time. So now I could refer to the notebook while I'm explaining it. So that's kind of the idea behind this whole thing. So I think I've explained how this works in the notebook, kinda. Although, did I explain the 2 volcano thing? Let's see. Oh, yeah, the wrench has a label for axis. Okay, wait. But I want it to be named Z, not Y. Because it's the Z axis. Oh, I can... Psh, okay. Ooh. Okay. What font is that? Okay, this already looks better. That's backwards. Okay. Kind of makes sense. I would probably need to like explain it. What's going on there. Oh yeah, I saved a YouTube video for later. It was like all fonts are free. Like you can't copyright a font, but I didn't watch the video. Speaking of fonts, I was thinking about fonts today. All right, let's... Should I add more volcanoes for fun? I think it might be fun to add a few more volcanoes for chaotic reasons, and maybe I can have them animate randomly. Now let's go crazy and have 5 meta balls moving around. Do we need 5? Do we need to do that? I don't think we need to do that. Never mind. Okay. Let's read through this real quick. Oh, the other thing I was going to add was 2 volcanoes. Did I? I didn't explain that. Okay. Notice how there are 2 volcanoes now. The reason is because as X and Y approach the centers of either circle, the Z, or the function, will go towards infinity. For example, if we approach x1, y1, let's say x1 minus like 0.1 away or something. Do we call this g of x? G of xy maybe I'll do 0.01 to kind of show how it's. Yeah, I don't know if this explains it a ton, but let's see. Maybe I should have used actual numbers. Might have been good. Which simplifies to yeah, I should use actual numbers. Yeah. Are they called singularities? Because they're going to infinity, like isn't a singularity like a black hole thing? I'm just basing that off of Interstellar. I think they're volcanoes. You know what they actually are? They look like the Pinocchio from the Desmos 3D challenge. I wonder if that equation is the exact same thing. Or maybe it's from the 2-line challenge. Let me check. Let's see. Yeah, it was like the surreal art of the 3D challenge. Oh yeah, that's on this account. Wait, let me save this. It was this. Oh no, they use complex numbers. Never mind. It reminds me of this one, but this is different. This equation's a lot different. Looks like, well, I guess, yeah, this looks different to me. Never mind. I was hoping it'd be the exact same. I think I should use an example. For example, if one meta ball is centered at, let's say, -2, +2, and the other is centered at, let's go 3, 3, 3, yeah, we can do 3, 3. Both with radius 1. Our equation becomes, let's make it H. Singularities are infinite discontinuities in 3 dimensions. Oh, so it really is the name of these things? Yeah, because it is not continuous at that point. like I was saying at the beginning of the stream, at 0, 0 here, there really isn't a point there, because in 3D it will be at infinity, something like that. Okay, so this gives us, okay, all right, so I kind of understood it. Now I want to Google that definition. No AI. This looks like a real university. Oh, look at this. Is God a singularity? What is Elon Musk's singularity? What will happen when we reach singularity? Oh, the event. So each of my metaballs is an event horizon? There's no... It's a waste of time. I don't know. I think it's interesting that this shape is singularity. But yeah, this is more in physics. I don't... Singularity... Okay. Yeah, it's the object is not defined, which is at that center of the circle. Right, because we'll be dividing by 0. Okay, cool. Oh. There's no point. Oh, I thought you were really saying I shouldn't talk about this because I'm finding this interesting. There's no point because there's no point at 0, 0 for that circle. Cool. Looks like it can get very complicated in real analysis, which I did not take, and complex analysis, which I did not take either. Okay. Cool. That's interesting. All right. Let me get back to this real quick. So let me change the equation. So I was just going to say radius 1 for simplicity. X plus 2. X minus 2. This one would be X minus 3. Oh, I did 2 X's. Y minus 3. Okay. And then maybe I'll show the graph each time, which is nice. Okay. Oh, I should show it in 2D and 3D. I don't know. I've seen Interstellar, but maybe I need to watch it again. Apparently Interstellar was pretty realistic for physics at the time it came out. So all that talk of like event horizons and stuff is accurate. Obviously, I don't think the ending is super accurate, but let's do a 3D graph. Okay, cool. And I guess we'll make them both blue for fun. Blue volcanoes. All right. And I'll just, for simplicity, Yeah, I don't think we're going to go to, yeah. True, I guess maybe it is correct. Let's call this Z4. What Z are we on? I don't even know. Now my naming is off. Because down here I called stuff Z4 and Z5. Jeez. Okay. Or no, Z3 and Z4. So this will be Z5. Okay, cool. So, but I want this to be a slider. And you know what? Maybe I can show. I don't know. Okay, that doesn't make any sense. Okay. And let's just go to 5. I don't think I need that. Okay. Now let's see. So I showed that. Now let's take the point. Let's take a point really close to one of the centers of the circle and see how it evaluates. Let's take a point really close to the center of one of the circles. Let's do 2.01. No, x was, what was the center of this circle? Negative 2, 2. So negative 2.01. And we'll do 2.01. When we evaluate h of xy, h of that stuff, negative 2.01 comma 2.01, we get and then I don't really want to evaluate that, but I guess I will. Um, 0.98. 25.1. Which equals oh, I can probably evaluate if I make this an expression. You can see that that left term, which we were really close to, kind of takes over. The right term barely was anything. How do I explain that? I don't know. Okay, I'm getting distracted here. Sorry. All right, cool. So I got distracted. We're still going. I guess I've been streaming for like 2 hours. I haven't streamed this long before. I guess this is the longest I've ever streamed. It's getting me to work on this notebook. I don't know if I need to at this point. Kind of makes sense. Are people working on notebooks on the side? Or are you guys playing video games on the side? We're just hanging out. Let's see. Someone's working on a paper. Do you have homework in the summer? Oh, you made a 3D. Do you want to send me the link to the 3D one? Using Arch. I don't know what that is. Oh, okay. What's your research again? I can't remember. I don't remember if we chatted on Discord when you joined it. You're sad because I don't know what Arch is. I'm pretty old. Oh, it's a Linux thing. Then I definitely don't know it. Got it. Okay. Aerodynamics. Oh, cool. Someone I went to middle school and high school with that I was in math class with for 6 years is a aerospace engineer at NASA, but he never has any time because of it. But maybe I could have been an engineer at NASA by now. Probably not, though. He was doing a bunch of engineering stuff as a kid, too. I was not. But I sometimes wonder if I should have studied engineering. Probably would have liked it. We're trying to draw a diagram straight in overleaf. Does overleaf just uses LaTeX, right? Or latex? Okay. Okay. What was I doing? Oh, maybe I'll repeat this. And I will show that this is 5,000 and this term is very small. So the I don't need this many decimal points. As you can see, the first term is quite large, 5,000, which is where, since we are very close to the center of that circle, the other term, which is, I don't know if this is explaining it anymore. I wonder if I could do like a commercial break thing to take a break. But I think this might be over. I think we might be done here. Yeah, I don't really have much else to do. I think I'm trying to think what I would do next. Oh, you sent me the link to the graph. Let's see. Oh, yes, I have Discord notifications. Let's see. Is this going to load? Okay, this is Lone Head Ruler's graph. Uh-oh, I think the stream might be dropping off. Okay, well now I'm learning what happens. Yeah. Oh my god. Okay, I think the hold up. I think the stream was lagging from the graph. So maybe that's what was happening before. Maybe I was playing something. 200 metaballs. Yeah, but since I'm running OBS and I've got other stuff open, maybe it does not like that. Okay. Maybe I can't remember what I was doing each time it crashed. Maybe the 3D graphs were like moving around or something. I don't know. Seems like if I open a really complex graph. Yeah. So maybe that's what's wrong. Maybe it's not I need an Ethernet cable. So I won't be opening that right now. Sorry. Pumpkin also put stuff in there. You did a procedural generation of a world with metaballs. Let me see the physics demo if that's gonna. Oh, cool. Let's see if this crashes it out. First of all, let's save this. It was probably my Wi-Fi earlier, yeah. But the same kind of thing happened. I was looking at the kilobytes per second on my OBS and it went down to like 0 in kind of the same way. So I don't know. This one seems to be simple enough to work. How did you... Oh, okay. Okay, look. This looks familiar. Yeah. We have the sum, which is adding up all the terms. Press reset. Ooh, cool. Ooh. Ugh. Yeah, it looks like you use the same equation. Because this is the sum of all these terms, x minus, and then it's a list squared. Looks like the same thing. Cool. Yeah. Ooh, I want to see the animation, how it works. So the lists, LNV. Where do LNV come from? Oh, I can search. I can do Control F. Oop. Okay, I guess it's LX and LY. Interesting. Cool. Yeah, there's probably a lot of cool stuff. I mean, I'm sure there's a lot of cool stuff with metaballs here. Oh, the animation's at the bottom. Oops. Can I search this? Lobby stuff. Yeah, this looks exactly like what we were doing. Similar stuff. These look like signed distance functions or something. Whoa. Cool. Oh, I guess you don't have to use just balls. Oh, yeah. We could have used other shapes. Oh. Yeah, we didn't have to use circles. Maybe it would be fun to take, let's see, is this the right account? Maybe it'd be fun to take a silly implicit. Oh no, it's the wrong account. Let me see if I have a silly implicit thing. Because I've been doing that. Okay, what if we took this thing I made for Reddit? What if the oh, ray marching. Oh, okay. Oh, you don't think I could do it? A meta square. Yeah. Okay, maybe this max min thing isn't the best for it. So you think if I made this equation, do you think if I just increase the exponent a ton? Yeah, we're still going. We're just kind of more hanging out now, though, and thinking of funny ideas with meta balls. Yeah, meta square would be fun. Let's see. Yeah, that's not what I want. Let me find. I think I could do this. I think I have Argman's equations of squares, and we can maybe find a good one to use. Potentially. We have this fun graph. Oh, but I think I saved it so that I could look at the animation. We have all these graphs of squares that Argman compiled. Math. Yeah, it could be fun. Let's see. Could we use this one? Let's see. Meta boxes. Yeah, I was thinking, yeah. I know I could do a huge N. Yeah. And it would approach a square. Like the super ellipse equation, right? Kind of like this. Although this has absolute value. Starfish. Cool. But I kind of want to try using this one. Call it meta boxes or meta squares. So if we move, that affects the blending. What would it look like in a 3D graph? Ooh. Let's see what this function fxy looks like in 3D. Good day. Ooh. What's this, an umbrella? We have a lot of Z's in this graph. Oh, it doesn't work like my volcano function. Darn. Still having fun with it though. Oh, it can't blend with other shapes. This is a fun function though. Okay, so it's the square root that's the problem. Should I look for a different one? Or do we have a better idea for... Okay, so I'll use max. Okay. All right, so I will use the max min thing. Okay. Let's... Wait, what am I doing wrong? Oh, 1. Okay. Okay, then how does that look in 3D? Ooh, pyramid. Didn't know that was the equation of the pyramid. Square with sibling 0, you're right. Whoops. Cool. All right. So if I do 2 of these, now, do you think I multiply them or something? You have to invert and add. Okay. Got it. Just want to see what adding does here. No. Okay, cool. Okay. Ooh, you know what? Let's use x1 and y1. And then once we meta squares. Meta squares. Well, that's fun. Let's use Z2. The meta square looks off. Uh-oh. It does look off. It looks like a... No, these are squares, right? No. Yeah, it's already 9:30. Are you on the East Coast, Pumpkin? The first one by 2. Oh, you're right. If I want it to look the exact same, you're right. How does this look? They individually look like a square. Kind of off though, no? Yeah, kind of like a square. But once they connect, oh, there's something going on. Like it's this thing. East Coast, yeah. Yeah, it's not exactly as smooth as Metaballs because there's something connecting here. Yeah, meta squares might not be the best. Yeah, they're pulling on each other. Yeah. Um, my other idea was to do no, that doesn't make sense. Trying to think what other shapes would be cool combining to each other. Whoa. Weird. Hmm. So you're saying whoa. No. Oh, I guess I could just copy yours. Let's see if it copies. Doesn't like that symbol. Weird. Very weird. Well, at least I can copy it now. Oh, square the max. Wait a second. Yeah, kind of looks nicer. I don't know. Not really. Yeah. Um. There we go. Yeah, figured it out at the same time. Ooh, that one looks cool. Whoa. I like this square thing. Okay, so I can still do the... Do I need the S? Yeah, I guess I do. Oh, without the S, it looks like the volcanoes. Okay. Okay. I guess I could define... That's okay. All right, I stopped talking. I feel like this stream needs to end in a minute. Now I'm just doing what Ranwanar says to do, which is fun still, but... let's Let's keep s equals 1. Ooh, now they're like squircles. Now we've got squircles. Does look nice. Cool. Yeah, it does look nice. Thanks, Ron Winor. Yeah, I didn't click it because I was worried it was gonna mess with the stream. So yeah, I'll check it after. Okay, I think I'm too tired to keep going. I stopped talking. This was fun. It's gonna go on my YouTube channel, I think. So maybe people will see how cool Notebook is and putting these graphs next to each other and explaining things. The challenge is going till the end of July. I don't know if I'll do another Notebook one, but maybe I'll do another graphing one. I don't know. We'll see. All right. Thanks, everyone. Bye.